So sometimes we need to add a notification to our systems. Like for example, if you have this system with this ultrasonic sensors here, and if let's say the robot is moving closer to the obstacle, it gives some alarm when it reach closer to the value, like this one here. So here again, I show you again here. So when the obstacle is getting closer, like my arms here, so it will sound some alarm there. So I show you one more time. This can be done by using these things here, which we call buzzer. So this is a buzzer. So this is a buzzer, or the piezo buzzer. So basically we will use this in this video here. So if you want to know how to coding this buzzer, or if you want to know more about the buzzer, so as usual, feel free to watch this video until the end. So there are two most common technologies used in buzzer designs, one is magnetic buzzer and one more is piezo buzzer. Many applications use either a magnetic or a piezo buzzer, but again, in this video I will show you the piezo buzzer. But usually for this decision regarding which of these two technologies to be used is based on your on many different constraints, based on your project. So a simple thing is magnetic buzzers usually operate at lower voltages and higher currents, which is around 1.5 volts to 12 volts with 20 milliamps, more than 20 milliamps of current, compared to the piezo buzzer that I shown in the introduction just now, which works between 12 to 220 volts with a very low value of currents, about less than 20 milliamps, which is suitable for the Arduino, especially because the output of the Arduino is just around 20 milliamps only. Again, the piezo buzzer, however, although the current is low, it has a greater maximum sound pressure level, or higher sound or higher pitch of sound capability that compared to the magnetic buzzer. And here, as you can see here in this figures here, this is the internal of the piezo buzzer, which it has this piezoelectric elements here, or piezoelectric ceramics, and which also composed with which also connect together with this metal plates here, with these metal plates here, which is using this adhesive here. And both sides of this piezoelectric ceramic plates here contains an electrode for electrical conductance. So this is what makes it can conduct electricity. So here, if I show you one example of the movement, so what happens here when an alternating voltage is applied to the piezo ceramic elements, the element extends and shrinks diametrically, like this one. So it shrink above and it shrink down parts of the piezo ceramic plates here, the ceramic plates here, which makes it vibrate rapidly. So it keeps shrinking and shrinking at different parts, and therefore it becomes a vibrations. So because the vibration is can be vibrate very rapidly, so that's why we can hear a sound generated by this buzzer. So this is the concept of piezo buzzer. Very simple concept and very simple working concepts, and therefore we can use it easily. And because of it only requires less than 5 voltage with 20 milliamps of currents only, and therefore we don't need extra power supply. We also don't need external circuitry to operate this piezo buzzer, and that's why we will use this in our circuits here, which as usual, if you want to construct the hardware, you can construct this hardware by following this circuits here, if you don't have ultrasonic sensor yet, or if this is your first video with me, so you don't need this part yet, just construct this buzzer only. So as you can see here, it will directly you can directly construct, you can directly connect both the positive terminal and the negative terminal here directly to the Arduino. The positive goes to the Arduino pin and the negative goes to the ground. But for me, I put this 100 ohms resistors here. Why I use this 100 ohms resistor is basically, if we look at this data sheet of this buzzer here, so as you can see here, the specification, the rated voltage is 3 volt DC. 3 volt DC. The operating current is operating voltage is 2 to 5 volts. So let's say we want to operate at 3 volt DC. So this part here is 3 volts, which means again our Arduino can output to 5 volts. So therefore here is 2 volt only. So 2 volt only. And then we see here, if we want to ensure there is no problem or there is no error later on, so we check the max rated current. So the max rated current for the one I use is 25 milliamps at 3 volt. So if we operate at 3 volt, it is about 25 milliamps, but this is the maximum. We don't want to operate at maximum. We want to operate at a lower value, because if we operate at maximum value, it might break or it might cause the buzzer here to break. And therefore what happens here, we need to limit it, maybe just about at 20 milliamps only. So 20 milliamps here. So because of that, just as usual, use the Ohm's law. So Ohm's law is equals to V equals to IR. So we want to know the R value, which is V over I. So V here, because we want to know the value of R here, so which means the V is 2 volt over with the 20 milliamps, and this is how we get the values of 100 ohms. So this is why I put 100 ohms inside this circuits here, just to limit the current, to make sure it does not break the piezo buzzer here. So this is the circuit for the Tinkercad or for the hardware. If you have the hardware, as usual, directly use the hardware. If you don't have the hardware, so as usual, let's look at this circuits here. This is the circuits from the previous lecture. So again, if you don't have the ultrasonic sensor, or if you don't watch the ultrasonic sensor videos yet, so feel free to watch the videos down below or up top. But if you don't have the ultrasonic sensor, don't worry, you can skip this part here, you can remove it from this circuits. And what you need to do is basically you can just connect like this for the buzzer. So at the pin 9, 100 ohms, resistors 100 ohms, and instead of choose buzzer, so you have the buzzer in the Proteus, but don't choose this one here. You can choose this one here actually, but because it can output in the sound card, in the computer sound card, so you can hear it in the speaker, in the speaker of your computer. But I choose the sounder here. So the sounder here, so the same thing is a piezo sounder model, which is also the outputs via the sound card. So remember, if you want to choose speaker or sounder or buzzer, make sure you choose the one that outputs via sound card. If you choose this one here or this one here, you can't you can simulate the sound. If you want to simulate the sound, you make sure you read it. It can output via the sound card. So that's it. So this is how you choose your components for the Proteus. So if you have Proteus, you can follow this one. If you need time to construct, as usual, just pause this video anytime you want. You can pause it here. If you want to watch, if you want to construct the circuits according to this Proteus here, but if you want to construct the circuit according to this Tinkercad here, hardware, by using hardware, so you can follow this circuit here. So as usual, you can pause any parts of this video, and whenever you are ready, then you can proceed with the next video. So I will stop this at this parts here only for this video. Any questions, any problems, any things related to these parts of the video, feel free to ask me, and you can also comment down below. And as usual, if this video is helpful for you, give a thumbs up so that I know it is helpful, and feel free to subscribe to this video, especially if you want to know more about Arduino or electronics in general. And therefore, that's it from me for this time around. Thank you very much for your attention. Stay safe, stay curious, and stay joyful. I'm Ikhwan. May God bless you. Assalamualaikum.